Hi, ma'am. We are in line.
Okay, thank you. So, very good afternoon, all the learners. Here I welcome to the first interactive session on deep learning course. So, today I'll be taking the queries one by one. Okay, I do have list of queries that are already being posted by the participants. So I'll read out each query and later on I'll try to answer one after the other. So the first question goes like this: learning vectorial representation of words, a prerequisite to learn week 11, that is RNN, GRU, LSTMs, and week 12 encoder decoder models, attention mechanism, attention over images. Can we go through week 11 and week 12 directly without the background of week 9? Here, suppose if you wish to find some sort of sequencing problem, if you are going to solve some kind of sequencing problem, then you at least need to know the how do we represent any sort of sequence. For example, how do I represent the sentence? Okay, so that representation is very much required, right? So for that sake, definitely the detailed background need to be studied, and later on you are free to work with either RNN or LSTMs, which are of your choice. So the next question is estimation theory, maximum likelihood, etc., and inferential statistics like confidence interval, hypothesis testing, etc., important for deep learning? Here, the answer would be definitely all the statistics will play a very important role. For example, we can say that suppose if I wish to if I wish to get the result based on some kind of inferences, right? So if I wish to get the result analysis in terms of some statistical analysis, right? Suppose my model may be giving some set of results, right? Output it may be generating. So that particular output it generates based on the given sample set, right? So what if I want to, if I need to generalize the result not only for the sample but for the entire population? So with that respect, definitely statistic will play a very important role. So here is the next query. Are the optimization techniques covered in this course are nonlinear optimization? Is convex optimization used in deep learning? And is convex optimization a linear optimization? Here, first of all, let me give you the brief introduction about the convex function. The convex function majorly it is used for the maybe in case of MSc for representing the regular you can say linear regression. So in that particular case, whenever we take a graph and a convex graph, and you consider any two different points on that particular graph, suppose those 2 points, if I'm able to draw a line and to touch both the ends, point 1 and point 2, I need to draw a line between using two ends, right? P1 and P2 as two different ends, right? Or you can say line endpoints are P1 and P2. Now, if I say that, suppose if my line itself crosses the curve, then I say my curve that we are considering, the function that we are considering is not a convex function, right? Similarly, if I consider any two different points on a given graph, right? And suppose if we say that those two different points are crossing the curve, right? Maybe P3 and P4, they are crossing a particular curve which is given, right? So in that case, we can consider the given curve is forming the non-convex, or it is following the non-convex property, right? So here, what is the advantage, or which particular function is being analyzed, and how do we analyze the convex and non-convex function? Suppose we do have the convex function, right? So in convex function, to get the minimal error, right? So we do always go for optimizing the error, right? So the optimizing the error is nothing but, suppose let's say we do have some set of data set. Let's take a data set where we have prepared a model, and let's say we have designed the model, and even we are able to develop the model that has been designed, right? So design and development part for the model is over. Now, if it is resulting in the lower lower error rate, right? So there I say that we may think that we have reached the optimal value, okay, most optimal value. But in case of convex function, we can have one optimal value as global optimal value, because as the nature of the curve itself suggests that nothing goes beyond this particular lower than this particular level, right? We can't proceed less than this. Then itself suggests that we are done with the work, right? As we know that once we have reached the lowest error, right, lowest loss, so in that particular case we can say that we have reached the global optimal point, right? As in convex, we only have the global optimal result. Whereas in case of non-convex functions, we may come across with multiple local optima and global optima as well, right? Suppose we are stuck in somewhere in local optima, then we need to extend the optimization technique, or we need to optimize the model in such a way that we need to come out of that particular local optima and reach to global optimal, right? And one more question which is related with this, or query which is related with the same question, is when do we or why we require this sort of a setting? For example, when should I get the result in terms of, or when should I go for complex function, and when should I go for simple function, or modeling the simple function? Suppose it basically deals with the kind of model that we are generating, or rather the problem in hand. Suppose the problem itself says that we do have the data points such that we do have, let's say we do have some positive points and we do have some negative points, right? And the data itself has been scattered in a plane such that if I take a line, if I draw a line between, if I am able to draw a line so as to differentiate between positive points and negative points, then definitely I do say that the function itself requires very simple function, so as to give or so as to separate the positive points with the negative points, right? So for this, the data might be linearly separable, right? If suppose the data itself is not linearly separable, in that case, if it is non-linearly separable, in that particular case, we need to think of a model which is more complex. The function itself we need to represent, which is following the complex representation of the model, right? So basically it all depends on the problem that you are going to solve. If the problem is very simple to model, then definitely you may require with less number of layers, with less number of even you can say the neurons, you can be able to solve it very easily, right? If the problem itself is very complex, then we need to develop the architecture accordingly by introducing more number of layers, or by introducing more number of even the neurons per layer, and so on, right? So here is the next query which is associated with this. In reality, I don't know what is why. Okay, and I need to find the approximate function. Why do we? Okay, this particular query is, for example, uh, we always know data is given to us, right? Some sort of data is given provided to us, and we do not have the data in terms of or we may not have the prior knowledge of the data itself, right? So how do we go ahead with it? For example, if we have the data set, and that particular data set is let's say non-linearly separable, then I myself explained just before this query is that we need to go for building some complex model, right? So when do I build the complex model? Whenever the data is very or it is non-linearly separable, right? So in that case, definitely I may not be able to get the predicted result y dash same as y, but definitely in that particular case, what are we trying to do is we are trying to approximate or predict my y hat, okay, predict the output which is more approximate, or which is more nearer to my y, right? So if number of we can say number of the problem itself is very complex, then at least we can give the solution which can approximate the problem, right? So that we do get the least error, right? So the next query is how to start learning implementation of deep learning in PyTorch. Kindly suggest a good course or the textbook for the beginners. So here, once you're done with this particular theory course, okay, once the concepts are clear to you, then definitely now you can go ahead with the practical implementation. Okay, for practical implementation specific to this question, the learner would like to know about the practical implementation with respect to PyTorch, right? So with respect to PyTorch, we do have the official website as pytorch.org, right? So you can refer that particular website, and definitely you will be getting you will be having many references under that particular website. For example, you may find some blogs, you may find some tutorials, right? So if you are able to solve those tutorials, then you can definitely, I'm sure you will be able to relate your practical with respect to your theory course, right? So the next query is knowledge of low-level image processing required for implementing the computer vision using deep learning? Okay. So with respect to this, definitely if you know the basics of image processing techniques, that would be an added advantage, right? So definitely not for the development point of view, or not for design and development of any deep learning model, but definitely to understand the problem itself. If you know the basics of image processing techniques, okay, one if if a particular person is using image processing, right, or images for solving the case studies, right? Or else suppose if a particular person is working with signals, then I do suggest that person, the one who is working with signal, then they should be able to know the basic concepts of signal processing, and later on the signals can be converted to images and they can be fed to deep learning models. But definitely if the case study you are solving is entirely dependent on the prepared data set, then I suggest to go ahead directly with developing the deep learning models. Or most recently, many researchers, authors, they are using the concept of GANs, right? Generative adversarial networks. So in that particular case also, what we do is we try to make use of some image processing techniques. For example, we may try to pre-process the images themselves, right? And later on, for example, we may apply some image enhancement techniques, or we may apply some sort of rotations for the with respect to images. Okay, we may apply some sort of scaling. So for all those will be done at the pre-processing level, and later on we do apply, we do go for generating the or implementing the GANs, right? So the next question here is, which are the latest activation functions which are used presently? So in this, suppose mostly authors, they do try based on given different set of activation functions, right? For example, sigmoid function, again, we do have, as studied in this particular course, you all might be aware of its disadvantages, right? Here, definitely advantage is it is able to represent the non-linear relationship between our input and the output. But the disadvantage is, as it has to go for high computational, the sigmoid function itself is in computationally, it's not efficient, right? So one of the issue with sigmoid is this. The other issue you can, you yourself have studied is nothing but the type of output that this particular sigmoid function is generating. Sometimes definitely while learning the parameters, right? So it may happen so that sometimes the learning itself will halt, right? Why the learning halts? Because of vanishing gradient problem, right? So the gradients maybe in one of the layer themselves. Okay, if I consider the thinned layer, okay, if one of the neuron is suffering that vanishing gradient problem, then we know the entire, it will affect the entire thinned network, right? So for that sake, this is the huge problem that most of the authors, they may face while using the sigmoid function as your activation function. Apart from that, if you use, mostly authors, researchers, they do use the RNNs. Why they do use the ReLU activation function? Basically, they do use ReLU activation function for with respect to CNN, right? So why do they use ReLU activation function? Because a sigmoid function has its set of disadvantages. For example, it may be suffering from gradient, vanishing gradient problem, or the sigmoid function itself may be providing us the a computationally inefficient one. Okay, it is resulting in computationally inefficient. So for that sake, whenever we try to use the ReLU activation function, these kind of problems will not be faced. So wherever convolutional neural network or with respect to images are your problems, you are dealing the problems with images, or you are building the deep neural network with respect to convolutional neural network. So in that case, it is always suggestible to use either ReLU, or you can say some the advanced functions of ReLU. For example, even you can use leaky ReLU as it's one of the advanced form of ReLU, right? So what about the other functions? For example, you might be using RNNs, right? You might be using RNNs in order to go for sequence learning problems. Okay, so in that you can always it is suggestible to use the activation function, that is tanh activation function, right? In a similar way, you can always go for output. You can always go for getting the either linear or softmax, again depending on the case studies, right, that you are looking into. So the next part is next query is which is the most important math component for deep learning, right? So here I can say that definitely deep learning and maths are very much related. For example, once we are into designing and developing of deep learning, then definitely at each point of time we need some set of mathematical operations that need to be used. For example, in case of convolutional neural network, we may need to perform some sort of convolutions with respect to images and the kernels, right? So for that sake, we need mathematics. Again, a linear algebra is most basic concepts that we are going to use in that. Again, in case of activation and pre-activation layers, we are going to use mathematical concepts, right? So again, in case of we need to go for some sort of optimization functions, right? So yes. Am I audible?
Yes, ma'am, you're audible.
Okay, thank you. Some sort of mathematical function is very important, right? And we may need to use those mathematical concepts. Basically, probability, statistics, and even linear algebra plays very important role, right? Okay, the next query is, in the industry, do we require machine learning knowledge to work in deep learning field, right? So as I said earlier, as this particular query, I have already answered for the other query as well, but I'll repeat. In case of deep learning, suppose my problem statement is, we do have the problem statement, or if I have been given the data which is not raw data, okay, and which has some set of pre-processed data, right? So in that particular case, no need of going through any of the ML techniques, okay, no need to apply any of the ML techniques. Directly we can work with deep learning, right? Suppose if your problem itself demands some set of feature engineering, okay, so if you want to study which particular feature is affecting my model, right? So in that case, in feature engineering, if you want to go for extracting the features by yourself, okay, where the programmer, the machine learning designer themselves are performing some set of feature engineering, right? So in that case, we don't even use the deep learning concept. But whereas in situation where we do not want to do hand coding, right? We do not want to perform some set of or we don't want to extract the features by ourselves, right? We want our machine to learn all the features, all the important features by itself. Then definitely we can skip the ML techniques, right? So the next question is, can an engineer work as a deep learning algorithm developer if one knows the DL concept and maths comfortably? Yes, definitely. Once you know the theoretical concepts, definitely you can work as a DL algorithm developer. Here is the next query. Is hardcore programming like C, C++ also needed, or only Python for data science is sufficient to work as DL algorithm developer? So the answer is definitely as an data scientist, if you wish to explore Python and if you wish to solve the problems which are related with deep learning, then I would say Python is sufficient, definitely, right? But the programming concepts must be clear to you, right? So then only you will be able to apply or you will be able to design your model. Fine. Why do we apply weight and bias in the neural network? So as I answered for the previous question, that is DL sufficient or do I need to use ML, right? So I answered my model, if it is able to extract the features, all the important features by itself, then that means no need of intervening the feature engineering part. Okay, in that case, I suggested you to go ahead with deep learning concepts, right? So the answer, the query, why do we apply weight and biases? Definitely, we want our model to extract the important features by itself, and maybe it might be giving more importance to certain kind of features, and it might be giving least importance to certain kind of features. Okay, so in that aspect, we need to go for applying weights to the neural networks, right? So definitely these neural networks, we want our models to learn the important features. Exactly, if I need to clear the difference between ML and DL, here DL is acting as a black box. We are only supplying the input and the output we are going to get. Okay, we do not know how our model is, or how our architecture is built, right? So we are built in the sense, definitely we ourselves as an engineer, we ourselves are planning the entire architecture, end-to-end architecture, how many layers we need and how many neurons we need. Okay, but definitely we are not interested how it is selecting which particular feature has been extracted and which particular feature has been left, right? It is doing by itself the automatically, right? So for that sake, we need to make sure that the weights need to be learned properly or correctly, so as to give at the end it should give the minimal error, or ideally it should give zero error. Okay, that means my predicted y, okay, y hat should be same as my y. For all these things, definitely I cannot change the x, the input in the given input cannot be changed, right? But what else can be changed? The only change that we can perform is with respect to learning the weights, right? So with that aspect, weight learning is more important, right? So why do we apply the biases in the network? Definitely, if we have any kind of biasness in our data set, initial biasness in our data set itself, then we need to go ahead for applying the bias to the neural network. Okay. The next query is, do cross-validation helps in reducing the overfitting? Okay. So here, when does overfitting, before going ahead with cross-validation, let's discuss on overfitting problem. When does overfitting problem comes? Whenever we do have a data set, okay, and where our model is performing very, very well on the trained data set, but it is not doing as good as the on the test data set. That means my model is able to learn the training data, but if any unknown data is given to my model, okay, not seen, okay, unknown, I mean to say not seen data, okay, the data that we are providing is not being given while training. So if that kind of problem, if that kind of an input is given to my model, then my model is not giving the, may not give the good result, right? So definitely it may happen, right? For example, we have divided the data itself in two different parts. One is training part, the other one is testing part. Suppose by chance that we have divided in such a way that the all the similar kind of data has been moved to one part, that is maybe training part, and all the similar data has been moved to testing part, right? Which is not exactly same, or some data set may itself may be very entirely different from the training data set. So in that particular case, we can say that our model has learned the weights, okay, and it is able to give the result, the optimized result, I can say optimized result on the training data set. But whenever we are testing on the test data set, as the test data set itself has very unique problem, right? Which that kind of problem has not been seen by our model earlier in the during the training phase. So maybe due to that, model has overfitted on the training data set, but not giving the good result or desirable result on the test data set. So there might be other issues why overfitting occurs. Maybe data set is very small. Maybe we are considering less number of features, or maybe integration problem. So in that particular case, we can say that we have class imbalance problem. Okay, due to class imbalance problem, also overfitting problem may arise, right? So now, how do we reduce the overfitting problem? Okay, overfitting problem can be reduced. Overfitting problem can be reduced by overfitting problem can be reduced by introducing some set of validations, for example, cross validation, right? So while introducing the cross validation, right? So in cross validation, what exactly the procedure that we adapt? We do divide the problem itself into number of folds, okay, where in multiple times, okay, for example, I may divide the entire data into multiple folds, right? And each time I do give, for example, I do have 9 different sets for the training, and one set I keep for the testing purpose. That means I do train my model for the based on the 9 different sets, okay, and I do test on the last based on the last set, and I do get the result, Okay, and similarly, in the next iteration, what we do is, again, we do keep the next iteration. I do pass next 9, and the one I'll keep for the testing purpose, right? Like this, I do perform multiple iterations. I do perform 10 different iterations, let's say. And in each iteration, I do keep one particular segment separately for testing purpose. So if I do this, our model will be able to generate the result with good accuracy. How it generates the result in terms of good accuracy? Because it is able to learn the entire data set at least once, right? For example, earlier in the first 9 has been used for training, and next one is used for testing. So in the next iteration, the leftover set is also used for training, and the one of them will be used for testing. Like this, in every iteration, I'll make sure that some part of the data set will be used for training and some part will be used for testing. In the next iteration, I'll again make sure that some part of the entire data set will be used for training and some part will be used for testing. Okay, so if I apply this particular method, definitely we can be able to reduce the problem of overfitting. Okay. The next query is, could you please suggest some resources for programming practice that are compatible with this particular course? Okay. So I suggest once to complete this particular course, once you complete this particular course, all the theory concepts with respect to convolution, with respect to major neural networks, for example, convolutional neural network, recurrent neural networks, or it is feed-forward neural networks. Once all the concepts are clear, then definitely you can go for practicing, right? You can refer all the official websites for Python are there, even the PyTorch are available, even the TensorFlow are available. In TensorFlow also, there are many more references, blogs, tutorials, right? And if you refer those, definitely you will be able to perform good hands-on on all these concepts that you have learned, right? And someone has given some link and asked, based on that particular link, asked the query, would you recommend doing these kind of assignments? See, as I suggested earlier also, you all must go for practicing the problems by implementing all the algorithms by yourself, right? So once you do hands-on, then it would be very much, you will be very much confident that yes, we ourselves have solved the problems in deep learning, right? And moreover, you refer any of the assignments, or you can refer any of the websites. Okay, and you will be able to get many deep learning problems, and even for you can go ahead with finding the problems based on certain kind of certain problems, right? For example, if someone wants to work with medical image analysis, right? And then we do have different data sets, okay, open data set which are available. So you can always refer those open data set and you can perform your implementation on that particular data set which is available. So free to go ahead with your implementation part. Either you need to sell, if you have the data set by yourself, then well and good. Otherwise also you will find many data sets which are available, like Physionet is there, right? And even some set of universities like Temple universities, they do upload the open data set, right? And UCI data set is available, Kaggle. So there are many resources which are available. You can refer any of them and you can start working with. here is the query, last query. I'm working as an engineer with good experience, but not in the data science field. I want to make job transition in GL and AI field. So after completing and passing this particular course, can I get job opportunities in DL and AI industry and start working? Definitely go ahead with once you do with this particular course, do hands-on practice, and once you do that, I suggest you to go for some kind of involving yourself in some kind of competitions. There are many organizations, there are many communities, they conduct some set of deep learning challenges. Okay, try to involve in some set of challenges, right? For example, Kaggle conducts for different set of problems, they do conduct the challenges. So try to at least involve in one or two challenges, and later on you can definitely you need to appear for depending on the requirement, maybe in some companies you may need to have the experience. So depending on your own experience plus the hands-on experience plus the challenges that you have faced, so based on all these, you will be ready to go ahead with it, right? So I've done with today's queries, all the queries. If any query is there with respect to deep learning course, you can ask. I think almost all queries have been answered.
There's one query regarding the optimizers taught in week 5 or week 6. I just was pretty much confused about the use of RMS prop and Adam optimizer, as sir suggested that it is quite well and good if we use Adam optimizer in most of the problems. But when I just implemented some of my models, and RMS prop was working better than Adam. So which one to prefer mostly?
See, Shreyansh, as I said earlier, definitely with some context, one optimization technique may work better, but we cannot generalize only one specific technique, right? So it depends on it varies from problem to problem, right? So for that sake, you need to, you have been given the clear concepts why, when, why, which one should you select, and later on you are free to test the different optimization techniques by yourself. But there is no generalized rule that you need to use for this problem, you need to use this. No, as such, no.
When we do cross validation, then in every epoch, after every possible epoch, do we need to do hyperparameter tuning or not? Or just after every possible epoch, do we need to update the hyperparameters?
Yes, you need to.
Okay, thank you.
Or with respect to each iteration, you need to.
Thank you.
With this, I'll close the session. Thank you so much for joining. If you have any further queries also, you are free to post it on the portal.